All right, we're going to take two and hope that everything goes good with this. Okay. All right. So just remember your pattern. Okay. I to the first is I to the second is -1, I to the third is I to the fourth is a +1. Okay. I to the 12. What you guys get? It was 1. 4 goes into 12 evenly. So when it goes in evenly with no remainder, that corresponds with I to the 4th power. Okay? What you get for 17? It is I. When you divide 17 by 4, oh, we did this one already. You get 16, you get a remainder of 1. That corresponds to I to the 1st power. What's I to the 26?
-1.
Very good. So that meant that when you divided 26 by 4, you got 6. So a remainder of 2 that corresponds to I to the 2nd, which is -1. Very good. And I to the 11th, it would be -I. When you divide 11 by 4, that goes in 2 times with a remainder of 3. Very good. So this one kind of went, used all of it. Did you have these as well? All right. What is I to the 2nd power? -1. That was one of the ones that you should know. I to the 36.
No, I got 1, right?
It should be 1. 36. 4 goes into 36 evenly. No remainder, so that corresponds with I to the 4th power. What about I to the 21st? I. Very good.
Would you like us to do the 210 with your counting method?
Definitely not. 210 is a prime example of why you should not use that counting method of going down the line and counting, okay? When I divide 210 by 4, that goes in 5 times. Bring down the 0, that goes in twice with the remainder of 2. So this is equal to what? -1. How are we with the powers of I?
Pretty good.
Okay, so just remember that pattern and I will be right. Okay? So, let's look at the operations now when it involves imaginary numbers. So, a complex number, okay, so this is one that's not a real number, is written in the form of A plus BI, okay, where A represents the real part and BI represents the imaginary part. Together, a real part with an imaginary part make a complex number, okay? So, we're going to write each of these in the form of A plus BI. How does the square root of -9 simplify?
Make it an exponent.
It becomes a 3i. Okay, it becomes a 3i. Don't forget about simplifying. That breaks down to the square root of 9, square root of -1. We know the square root of -1 is I, and the square root of 9 is 3. There is the BI part. Does everybody see that? B would be 3. And then the 6 just gets added on. And that is the complex number, 6 plus 3i.
So if you're adding, you can't add them, but if you're multiplying, you can?
Yes.
Okay.
Adding is just like with radicals, they have to be alike. So the only way we can add imaginary to another is if it's another imaginary number.
I thought it was a lie.
So,
No, it's a plus. All these are pluses. Yeah, all these are pluses.
So the square root goes to the back.
Mm-hmm. Yes. So it can be in that form. So if anything, like kind of circle, highlight that form so you make sure you write it in that form.
just a quick question.
Yes.
The square root of 9 would be 3.
Yes. And the square root of -1 is I.
Will you always flip them?
In this case, because the square root part was first, you always want it on the back end. Like in the third one, we're not going to have to flip them because the square root of the negative number is the second piece, not the first piece. What about square root of -18? How does that break down? 9 and 2. There is a -1 in there as well. What's the square root of 9?
3.
Square root of -1, I. And then we have the square root of 2 afterwards. That plus 7 goes in the front. So 7 plus And that's that complex number. When I do number 10, what is the square root of negative 49? 7i. Anytime there's a negative underneath your square root, you'll always have an I, so you'll have 10 plus 7i. Still applying that skill of simplifying radicals. Now we just have i's. Ooh, what about this next one? 2 times the square root of negative 16 plus 6. Yes, the square root of negative 16 turns into a 4i. So we're going to multiply that 4i by the 2 that's already on the outside. What is that? 8i. And then that 6 goes in the front. Questions? So again, the only time we can add complex numbers is if they are complex numbers. If they are imaginary numbers. Okay? We cannot add a real number to an imaginary number. So when you're doing things like this, you want to combine the real parts and you want to combine the imaginary parts separately. Okay? It's like combining like terms when you're adding and subtracting with a complex number. Okay? I have 4 minus I plus 3 plus 2i. I'm going to add 4 with what number? 3. What's 4 plus 3? 7. And then I'm going to add negative I with 2i. And that's just going to become what? No, we're adding, not multiplying. It's just going to become a positive 1i. And that's our answer. So when we're combining these, it's almost like we're just adding the coefficients.
How did that just become a positive 1i if there was still like the 2 in front of it?
Because we had a negative 1i
Okay.
plus 2i, so it's basically negative 1 plus 2.
Okay.
Over here, I'm going to add 3 with what?
2.
And that gives me what? 5. And then what's 1i minus 3i?
Negative 2i.
And you're done. Okay? Be careful with the subtractions. You are subtracting this entire parenthesis. So if I wanted to, I could rewrite it without the parenthesis, but I have to make sure that I distribute that negative through. Okay? So this becomes a minus 1, but a positive 10i. Be careful. Do not get tripped up with that. Distribute that negative all the way over to that second parenthesis. So what's 7 minus 1? And then what's negative 5i plus 10i? And we're done. How is this? It's kind of good. It is, but there are places where you can make like really small mistakes. Like that negative there, that's one of those where you can make a small mistake and change your whole answer. Not remembering your pattern, getting your pattern mixed up, that's another one with your powers of I. Okay? So just be careful. All right? Now on these, okay, these ones here. I want you guys to try some of these on your own. It is on the back, so when you flip it over, I want you guys to try these. Okay? Try to add and subtract these. So, remember, distribute the negative over, that just drops the parentheses. So this becomes 6 minus 2 minus 9i. Combine your like terms from there, and what's your answer for the first one?
4 minus 9i.
4 minus 9i. Okay? And then you're done with that. What did you guys get for an answer for the second one?
8 plus 9i.
Okay, I heard both a plus and a minus 9i. Is it plus 9i or is it minus 9i? It is minus 9i. When you distribute that negative over, it becomes 6 plus 2 minus 9i. Very good. Now this one was a doozy. Well, not so much, but make sure you distribute the negative here. And then you're just adding these. So this became a 4 plus 1 minus 12i. And then what about that back part?
Plus 8.
It stays the same. Think about a plus and a minus make a what? When you distribute, when you multiply them. What does that make? It makes a negative. And that becomes, it ends up just stays the same when it's a plus. The plus doesn't change it, it's the minus that really changes it. Combining our like terms, 1 plus 4 minus 8, 3, negative 12i plus 4i. Now, yes, you don't have to do this. Okay, if you can see it just straight off without the distributing, then you're totally good. Okay, you don't have to do it that particular way. That's just for those who might not be able to see why it turned into a negative 3 versus something else. Okay? Questions on adding or subtracting? Now for the multiplying. Okay? When you multiply, you got to remember your powers of odd. Okay? Because now they're more like variables and less like just, like placeholders. When you multiply, you just, you multiply like regular. What's 5 times negative 4? Negative 20. What's I times I? I squared. Once you've multiplied, you have to simplify. I squared equals negative 1. So then this turns into negative 20 times a negative 1. And what is that?
Negative. Positive.
A positive 20. And that's your answer. So 5i times a negative 4i becomes a positive 20 because I squared turned into negative 1. Okay. So the second one was 12 times 7. 84. I times I. I squared turns into what?
Negative 1.
And what's 84 times negative 1? So when it comes to multiplying, you got to know your powers of I. Otherwise, it's not going to be fully simplified. So, for example, this would be like a 2-point question on a test. Here's your 1 point for multiplying correctly, but your final point comes from actually simplifying. Yeah, see that? Okay. Those are the easy ones where you're just multiplying a monomial by a monomial, but what if you're multiplying a binomial? You got a FOIL, okay? You can't escape it. It's everywhere, okay? First, 8 times 2. What's 8 times 2? 16. Outer. What's 8 times a negative 3i?
Negative 24i.
24i. Inner. What's 5i times 2? 10i. And my last. What is 5i times a negative 3i?
Negative 2i squared.
Negative 15i squared. Now, you can go further. Okay? You can go further. What is I squared? Negative 1. So this is a negative 15 times a negative 1, which becomes what? Positive 15. Can I combine like terms here with the negative 24i plus 10i? What does that become? Negative 14i. So I have 16 minus 14i plus 15. Can I combine any other like terms?
16.
With 16 plus 15.
31.
So 31 minus 14i, and that is my answer once I multiply those two complex numbers. Turns into a simple complex number. Okay? I want you guys to try the second one. Try the second one. Let's see. Okay? First. As in like first. Negative 30. Outer.
Positive 18i.
Inner.
Plus 10i.
Outer.
Negative 6i squared.
I squared turns into a.
Negative 1.
So negative 6 times a negative 1.
Positive 6.
So I have a positive 6. Bring down my negative 30. Combine my like terms to get, and continue to combine like terms. My final answer is,
Negative 24 plus 28.
did you guys get that?
Yes.
Awesome, awesome, awesome.
Wait.
What? What happened?
Alright, negative 30. Okay.
A negative times a negative makes a positive, so that becomes a positive 18i. And then a positive times a negative gives you a negative 6.
I just messed up on moving that. That's fine.
So, to summarize what we've done today, okay, we've talked about the imaginary number I, okay, and when it's used. You guys also dealt with the powers of I raised to different powers and how to find it. Remember, the shorter way, divide by 4 and look at the remainder, okay? Then we also did operations, adding, subtracting, multiplying. Dividing is a whole nother beast that we're spending Wednesday doing, okay? Dividing is a different beast, okay? So, do we have any questions so far?
No.
All right.